Lovers, nice to see you again. I'm Dodi Ferianto. Okay, this time we will discuss about one of PISA problems, PISA mathematics problems. Yeah, I these problems is taken from PISA problems books. Yes, in internet. Okay, let's start. Read the problems. The title of the problems is apples. Oh, the font is very tiny. Let me zoom. A farmer plants apple trees in a square pattern. In order to protect the apple trees against the wind, he plants conifer trees all around our orchard. Here you see a diagram of this situation where you can see the pattern of apple trees and conifer trees for any number n. Let's say Sn of rows of apple trees. If n is equal 1, if n is 1, we can see that this is this apple trees. This apple trees, and around is conifer trees. When n is 2, this is apple trees. 4 apple trees, and the around is are conifer trees. And so on. First question, complete the table. Number of apple trees, there are 2 columns. First column is number of apple trees, and second column is number of conifer trees. When n is equal 1, then number of conifer trees is 8. Number of apple trees 4. We can see, or maybe first we can count. We can count. Let me to erase this first. We count together. This is 5, so 2 times 5, plus this is 3, right? 3, this is 3, or 2 times 3 plus 2 times 3, so we can write as 2 times 5 plus 3 is equal 2 times 8. This is 16. When number of apple trees is 3, or not, sorry, not 3. When n is 3, number of apple tree is 9. Is 9. 9. And the number of conifer trees are, let's count together. 1, 2, 3, 4, 5, 6, 7. 7. 2 times 7, right? 2 times 7 plus 2 times 1, 2, 3, 4, 5. It's equal 2 times 7 plus 2 is equal 2 times 9. Or 18. And when n is 4, number of apple trees is 4 square. 4 square is 16. Can you guess the number of conifer trees? If you don't confidence, let's count again, yeah. 1 2 3 4 5 6 7 8 9 9, yeah. 2 times 9, okay. 2 times 9 plus, okay, this is 2 times 9, 1 2 3 4 5 6 7, yes, plus 2 times 7, or equals 2 times 9 plus, oh sorry, this is not, this is I think I got wrong. This is not 2. Oh no, this is not 2, okay, not 9, so this is wrong too. Okay, okay, this is 5, right? Why so difficult to erase this? 5, yeah, 5, so we got 2 times 12, so we got 24. Okay, this is 24. Okay, and this is 9 plus 7, right? Yes, 9 plus 7, or 2 times 16, yes, equal 32. Yes, 32. And when n is 5, number of apple trees is, yes, correct, yeah, 5 square or 25. Okay, and number of conifer trees is, can you guess it? Okay, 2 times 11 plus 2 times 9. if you cannot believe, yeah, you can draw, but I won't. Is equal to 2 times 11 plus 9 is equal to 2 times 20 is equal 40. Okay, 40. Okay, yeah. Okay, maybe I want to rewrite, yeah. When n is 1, number of apple trees is 1, number of conifer trees is 8. Okay, when n is 2, now number of apple trees is 4. This is conifer trees is 16. Number of, when n is 3, number of apple trees is 9. Number of conifer trees is 24. When n is 4, number of apple trees is 16, but number of conifer trees is 32. And when n is 5, number of apple trees is 25, and number of conifer trees is 40. Okay, can you find the pattern? Okay, for apple trees is clear. Yeah, it's clear that this is we can get the formula. The formula is n square when n is n, or okay, this is n. Okay, number of apple trees is n square. How about number of conifer trees? Yes, maybe you can make the pattern. You can make the formula by this pattern. Yes. Okay. Yes. Or maybe when you see the result of the numbers conifer trees, yeah, one by one, yeah, let's see, 8, 16, 24, 32, and 40. Can you guess the pattern? Yes, they are a multiple of 8, right? This is 1 times 8, this is 2 times 8, and this is 3 times 8, and this is 4 times 8, this is 5 times 8. Okay, can we construct from from this pattern to this pattern. Okay, it's interesting to explore. Okay, let's explore. Yeah, let's to explore. This is to the when n is equal n n is equal n. Okay, weird to hear, but okay. When n is equal n here, right? Yeah, number of conifer trees okay, is, if we want to explore this pattern, right, we want to prove that this pattern is equal for this pattern. Okay, is 2 times okay, this is when n is 1, n is 1, n is 1, n is 2, and is 3, 4, and so on, right? No, this, oh no, ini okay, ini okay, this for n is 2, 3, 4, 5. Okay, we have to know the pattern, yeah, the pattern of every the first number in this form. Okay, I think its number is 2 times n plus 1, right? 2 times n plus 1. Yes, when 2 times 4 plus 1 is 9. Yes, 2 times 5 plus 1 is 11. 2 times 3 plus 1 is 7, and 2 times 2 plus 1 is 5. Okay, so this we can write this is 2 times n plus 1. Okay, plus, okay, maybe I'll make a bracket, yeah, bracket, yes. Sorry. Okay, and how about this? 3, 5, 2, 7, 9. Yes, this is okay. Let's see. 3 plus 2 plus, okay, when n is equal 1, this is when n is equal 1, we can make the pattern 2 times 3, okay, 3 plus 1, okay, 3 plus 1. Okay, this is 2 times n plus 1 minus 2. Okay, right? Okay, 2 times plus 1 minus 2. So we can say that this is 2 times n minus 1. Okay, right? When n is 3, 2 times n minus 1. Yeah. Okay, when this is n4, yeah, 2 times 4 minus 1 is 7, right? 2 times 5 minus 1 is 9. Okay, right? Okay, this we get 4 times n, yeah. Yes, 2 times 4 times n, yeah. So we get, this is 8 times n, or 8n. Yes, correct. Yeah, this is when n is n times 8 or 8n. Okay, we has proof the pattern is the same. Okay, continue to the next question. Okay, there are 3 questions. Okay, continue. Let's continue to the second question. There are 2 formula you can use to calculate the number of apple trees and the number of conifer trees for the pattern described above. tense. Sorry, I always replace that bad word to the word tense. Okay, number of apple trees is equal n square, right? Number of conifer trees is equal 8n. Why we so full? Why we have? Why we must look the pattern? But the next question say about the pattern. Okay, where n is the number of rows of apple trees. Okay, there is a value of n for which the number of apple trees equals the number of conifer trees. Okay, find the value of n and show your method of calculating this. Okay, this condition if the number of apple trees is equal the number of conifer trees. Okay, the number of apple trees is n square equal, the situation is equal the number of conifer trees is 8 times n. Okay, because n is not non-negative, is what is that, not integer, okay, it's not 0, so we can divide it two sides by n. Okay, we divide it two sides by n and we get n is equal to 8. So when the number of apple trees is equal to the conifer trees is when n is equal 8. Okay, let's continue the next question. The third question is, suppose the farmer wants to make a much larger orchard with many rows of trees. Okay, as the farmer makes the orchard bigger, okay, which will increase more quickly? The question is, which will increase more quickly, the number of apple trees or the number of conifer trees? Explain how you found your answer. Okay, let's see the formula of number of apple trees and formula of number of conifer trees. Yes, number of apple trees is n square and number of conifer trees is 8 times n. Okay, I think it's clearly that quadratic function will be larger than this is linear function, right? This is quadratic function, and this is a linear function. Yes, when we draw the function graph, okay, quadratic function like this, right? Sorry, maybe I want to copy this. Okay, no, not copy, but I want to move. Okay, this is a graph of number apple trees, yes, quadratic, and okay, 8 times n. Okay, 8 times n will have the graph like this. Okay, this is a number of conifer trees, and this is what we say, intersection between two graph. This is happen when n is equal 8, right? Okay, so when the farmer want to want to make a much larger orchard, yeah, so we can guess that the number of apple trees more increase more quickly. Okay, I think that's all. Don't forget to like, share and subscribe this channel. Yeah. Nice to see you.